Welcome to another session. This is lesson 2 polynomial. We have been solving some problems under the topic division algorithm for polynomial. This is the second problem from exercise 2.3. Let's try solving. Again some technical issues. I don't know what is the problem is. The exponent not placed in the correct order, not fixed in the correct place. But don't worry, I will write it down each question while doing the problem. Okay, this is the first one. So first I read the question. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. Which means we are simply going to do the long division and we'll see whether we get 0 as a remainder or not. Once we get 0, then the first polynomial, this one, is the factor of the second one. This is what we are going to do with all three problems. I remind you again, if we get 0 as a remainder, then the first polynomial is the factor of second one. If we get some remainder, any number, then the first polynomial is not the factor of second polynomial. This was the concept. Let's do. First of all, let's check whether our polynomial is in the correct order or not, whether we are missing some terms or not. So here p of x is in the correct order, so I write it as it is. But for g of x, we are missing one term, which is t. So I put 0 for t term, and minus 3. Okay, I write everything in the correct place. Okay, for the first term, I'm going to do what we supposed to do. Yes, first term. This is what we used to do while doing the long division, right? So I put it the 2t square as a first term. Then I multiply each term. Don't forget to multiply 0 as well. I done. I hope till this you don't have any doubt. For the second term, sorry, I write it again. This is wrong. This will cut. Sorry, this will come 3t cube. I forgot to write. Okay. Now everything fine. Let's continue. So for the second term, I divide these. So second term is 3t. So plus 3t, and I multiply. Here I cut two terms, 3t cube and 9t. So the remaining is 4t square minus 12. For the third term, I got 4. So I add 4 on top, and the same will come, 4t square and 0. So I forgot to write 0 here, and again 0 and minus 12. So once I change the sign, I get 0 as a remainder. Let me conclude this. Since we get 0 as a remainder, t square minus 3 is a factor of 2t4 plus 3t cube minus 2t square minus 9t plus 2. Sorry, minus 12. This is how you conclude this type of problem. So I think other problems like 2 and 3 following the same procedure. So you can try it on. I already solved so many problems related the long division. So you can check that out if you have still doubt on this. So let me move on to the third problem from exercise 2.3, which is obtain all the other zeros of polynomial. This one, if two of its zeros are root 5 by 3 and minus root 5 by 3. We already solved some problem which is same as this. Here we don't have any divisor, only dividend we have, which is p of x. This is what p of x dividend is, but we can derive the divisor using the zeros. From the zeros we can derive the divisor. Let's see how to do this. Since two zeros are given, we able to write the zeros like this: x minus root 5 by 3 and x plus root 5 by 3, this way. So which is in the a minus b and a plus b format. So we get a square plus minus b square. Here a is x, b is root 5 by 3. So I get, for a square I write x square, for b square root 5 by 3 whole square. After I further simplified, this is what our final answer: x square minus 5 by 3. So since this is the zeros of this polynomial, and this is also the factor of this polynomial, every time before performing the long division, you check whether all the terms of divisor and dividend is in the correct order or not. So here p of x is in the correct order, not g of x, which is divisor. So here we have x square minus 5 by 3 only. We don't have the term x, so I add 0 for the term x. Now we are ready to do the long division. I write it everything in the proper place. So for the first term I divide these two, so 3x square. Then I multiply each term, so 3x4 plus 0. So while multiplying 3x square into minus 5 by 3, I cut 3, the remaining are minus 5x square. This is how to do whenever you multiply minus 5 by 3 with other terms. I done the calculations, so I got the remainder 0. So I write the quotient, which is in quadratic form, quadratic polynomial. So I'm going to split the middle term and find the other two zeros. While splitting, I get x plus 1 and 3x plus 3. Then I assumed each term as 0. This is how we used to do. So I get x equals to minus 1 and x equals to minus 1 for both values. So the zeros are minus 1, minus 1. We already know two zeros, which are root 5 by 3 and minus root 5 by 3. Hope you understand this. Thank you.